Okay, so the first part of our look at stereoisomerism is what's going to be the Cis Trans Isomerism. Okay, so this is shown in the bottom left of the graphic right here. This is where rotation is basically restricted about certain bonds, either due to the presence of a double bond, a pi bond, or the presence of a ring. All right, so we're going to have a look at a couple examples here, and we're going to begin with cis trans isomerism about a double bond. So the first molecule we're going to look at is but2-ene. All right, so shown here on the left is cis but2-ene. All right, and you can see that if I take this model, which features the double bond, and I try to actually twist about that double bond, I can't. If I twist, let's say, between carbons 1 and 2 or 2 and 4, I can twist in both of the molecules, all right? But it's something about that bond between 2 and 3 that doesn't allow me to interconvert. This is the presence of the pi bond. Okay, so this actually means that the hydrogens and the CH3s are locked into their arrangements either above or below, or one above and one below the plane of that bond. All right, the next example is trans 1,2-dichlorocyclopropane and cis 1,2-dichlorocyclopropane, which feature the chlorine atoms shown in purple here, either both above the ring in the cis example, or it could be below as well, or above and below in the trans example. Now, because of the presence of the ring, there's no pi bond here, but the ring doesn't allow me to actually twist and rearrange this molecule such that I can change the trans model into the cis or vice versa. Okay, so the presence of the ring actually has the same effect as a pi bond did in the but2-ene type example. All right, these two molecules will display different physical properties as all of these isomers will. All right, the final example we're going to look at would be 1,2-dichlorocyclopropane. Again, cyclobutane. Again, similar as the cyclopropane example. This is just a four-membered ring. The chlorines are locked into positions either above and below, or either above or both below for the cis conformer here. So again, it's the presence of the ring that means that I can't interconvert without breaking a bond. So you can see here, I take the model apart, I rearrange some atoms, all right, and I can turn one into the other. But short of doing that, I can't interconvert. All right, so take a minute here and try to draw cis but2-ene dioic acid and the trans isomer as well. I'd like you to think about which could have the higher melting point and which could have the higher boiling point. Come see me when you have a possible solution.